Hi, my name is Sai Charan Reddy. I'm from Group 12. In this screen recording, I'll explain code to implement naive Bayes in Scala and also demonstrate the same using card data example. I'll demonstrate this example in Amazon EMR cluster. So to work with Scala, install Scala IDE for Eclipse, create a normal Maven project, and in configure section, make sure you add Scala nature. Once that is done, go to pom.xml, add these two dependencies, Spark Core 2.11, Spark mlib 2.11. Then create a package name which should match the Maven package. Once you have created, you can start coding. So make sure you have this package name and you implement these libraries. So create a car class, and this car class should match with the car data that we have taken. So this is our car data. So as you can see, the first row, so we can compare with this first row. Here the buying is very high, maintenance is very high, doors are 2, persons 2, boot is small, safety is low, and that car class is inaccurate. So you can also find accurate. So you can see here. And in the main method, we are passing the data and split the rows using string.split. If the row length is not 7, then include that as none. Make sure that is none. And so this is the Spark conf. It's just a configuration of a Spark application, and using Spark configuration we'll set Spark parameters as key value pairs and set the app name and set master to local, and attach this conf to Spark context. Here the Spark context is a main, it's an entry gate in Spark application. It is mainly used to connect Spark cluster, and it is also used to create RDDs. So take the input from the command line and convert that into an RDD using Spark context. Once that is done, convert all the strings which are present here to double values. Once strings are converted to double, we have to create a labeled point. Here we'll be having a label which is the car class and all other features over here. So make sure that the feature should be in vectors format and the label should be in double format and the data in the vector should be in double format. So once this is done, we are splitting the data into two parts, where the 70% goes to the training data as a training data and 30% goes as a testing data. So we mean that in this huge 1000 records, we'll separate 700 records for training and we'll be using remaining 300 records for testing. So take that into a variable and using naive Bayes.train, train the data, set the lambda to 1.0, set the model type to multinomial. Once that is done, use test data to map and predict using the model that we have trained. So the output we get is the prediction and the label name. On the right hand side we'll be having the predictions, on the left hand side we'll be having the predictions, and on the right hand side we'll be having the old labels. So these are the new labels that are predicted and these are the old labels. And you can also print this accuracy. In our case it's 97%, and we'll be printing this prediction and label data into a text file to actually see the results. So once everything is done, create a jar. Don't create a Maven jar. Go to File, go to Export, and in the Java section go to Jar File and create the jar. Once the jar is created, upload the jar in Amazon S. Copy card.data and jar file into S3, and from S3 copy the jar into our instance. You can use this command to copy jar from S3 to your instance. Once you copy, use this command to execute the jar. So in this command, this is your package name, this is your object name, and this is your jar, and your first input, which is arg0. So this is the input data, sample input data, and this is where we are storing the output text file. So execute this command. This is the Spark output. I want it to save to Spark output, and I am taking data.txt as a sample input, and my jar name is demo_car_re.jar. I'm using that. And my package name is com.group12.demo. Make sure that your package name is correct. I think we are good to go. I think now the program is successfully executed. Go to EMR, go to this S3 bucket, refresh the page. So in Spark output, this is our output text file. So just download it to view it. So this is the final output we got. Here the first field is the actual prediction, and the second one is just the old label. So the first one is a new label and the second one is old label. So this is how we use naive Bayes to predict the new car class from the given training data. So thank you for listening.